In part A, they are compound inequalities, so we have to finish simplify one by one. And finally, maybe we can simplify the expression to give one final simpler conclusion. The first inequality, I just both sides times 7. So 2 times 7 we get 14. And beware that because I multiply both sides by positive value, so do not trigger a change in the direction. 14x minus 28, and then we want to group all x together, all constant together. After that, I want x, I don't want negative 17, so I divide both sides by negative 17 to remove it. But be reminded that if you divide both sides by negative, it's trigger a change in the direction, it will become opposite direction. The reason is the same as you compare 1 and 3. 3 is larger. But however, if you consider negative 1 and negative 3, you will find that negative 1 is larger instead. Therefore, x is larger or equal to 2. This is the simplified conclusion for this complicated inequality. But don't forget that we still need to handle with the second one, and we are applying n case. So 5x larger than 23, and then both sides divided by 5. Again, 5 is positive, so no need to change the direction. This is the conclusion for the second one. Now we are going to consider these two requirements together by using n case and see whether we can simplify the expression. Then in your draft, we are going to draw a number line, and then we find that 2 is smaller than 23 over 5, that means 4.6. And then the first requirement, larger or equal to 2. The second requirement is larger than 4.6. Now, the number line, the whole number line are separated to 3 different regions. We are going to find which region fulfill the requirement, both, because we are talking about n. The first region is not okay because it do not fulfill anyone. The second region is not okay also because we are talking about both n. It's just fulfill the first one but not the second one, so it's not satisfying the inequality. And only the last region here is satisfied the first one and also covered by the second requirement. So our solution is the most right hand side region, and our answer is the name of this region which fulfill both requirements. The name of the first region is called x, any x smaller than 2. The middle region is called x between 2 and 4.6, and the last region is called x larger than 4.6. This region is all the x which is larger than 4.6. So this is our final answer for part A, and you need to give me the conclusion by using the symbol therefore. X is larger than 23 over 5, or you may say x is larger than 4.6. This one is the simplified answer of this one and this one. Therefore, this will deserve one final answer mark for part A. And then in part B, we are going to find a least integer. Integer that means whole number, which is the smallest one, fulfill the requirement. The best method is use the number line and then write down some integer on the number line. We find that 3 or 4 is not qualified because it's not in our target region yet. And then the first integer within the region is 5. So this is the least number, least integer, fulfill the requirement mentioned in A. Then you just write down the number directly. The integer is 5.